Hello, everybody. Thank you very much for coming. Today, we're going to tell you all about OpenTelemetry and Kubernetes and why it's all about love. It's going to be introductory, going into some more advanced topics. That is the goal. My name is Jacob Aronoff. I'm a founding engineer at Taro. I'm a maintainer for the OTel operator. I'm also a maintainer for the OTel Helm charts.
And I am Christos Markou, principal software engineer at Elastic, also approver for the OpenTelemetry Collector contrib project and approver for various areas in Semantic Conventions project, CNCF ambassador as well, so super excited to be here today, and yeah, let's get started.
Yeah, let's get going. So our goals today are to help you understand OpenTelemetry basics for Kubernetes monitoring. We're going to demonstrate some reference architectures for observing Kubernetes, and we'll also share some trade-offs that you may encounter. We'll start by introducing OTel, introducing general telemetry concepts. We'll then go into telemetry collection in Kubernetes, deployment strategies and implementation, operators and Helm charts, and then we'll end with those operational considerations. So to begin, OTel and Kube. What's OTel? Many of you are probably already aware. We're the second largest project in the CNCF, last time I checked. It's an open source standard for telemetry, metrics, logs, and traces. I am not going to be talking about profiles today. I apologize. We are a vendor-neutral telemetry collection as well, and it's a vast ecosystem of tooling maintained by a bunch of companies. So observability in Kubernetes, we're going to talk about the three main signals, metrics, traces, and logs. Metrics explore the current and historical system state, each point value at a timestamp with some attached metadata. In Kubernetes, pretty much all the time, these are going to be emitted through Prometheus, and it's important that we consider that. We'll talk about that later. Traces are, I think, the most powerful telemetry type. They demonstrate the flow of a request through a set of services. It allows fine-grained understanding of why a behavior occurred. Some Kubernetes services also now offer tracing through OpenTelemetry, so you can capture those, which is super helpful. Lastly, logs, they show diagnostic information. Kubernetes services log plenty. And Kubernetes has great support for this, right? We can tail logs, we can collect them very easily through a file, super simple. In OTel, as I mentioned earlier, pods emit metrics through Prometheus. So you might have a Prometheus scraper getting those metrics. Important to note, though, is that this is pull-based, right? And this is important because pods, as we know, are ephemeral, meaning that they can die at any time. In a pull-based system, you might lose some of that data. You could imagine if you have a short-lived job, scraping might not be the right system for that. OTel, however, is a push-based system, so it's better for short-lived jobs, better for things where you might be cycling pods pretty quickly. But OTel actually does support both. We'll talk about that a little bit later. Next major consideration before we really dive in is really cluster architecture stuff. So when you're observing Kubernetes in a cluster, if you're doing multiple clusters, it is vital to annotate your data with the cluster name, the namespace, the deployment, everything that is there so that you can differentiate between your environments. OTel has really rich semantic conventions for this. Christos will talk about that a bit later. And finally, OTel's Kubernetes offerings, a lot of the things that I work on, will do this automatically for you. Now on to Christos to talk about the OTel collector.
Thank you. So probably the collector is the most critical component of OpenTelemetry when it comes to Kubernetes monitoring and observability. And I need to move on. So yeah, it's essentially a vendor-neutral telemetry agent, which allows us to build telemetry pipelines. And in this, we can ingest telemetry through receiver components. We can then transform and enrich our telemetry using the processor components. And eventually, we can send the data to any observability backend using the available exporters. So the collector can run as an agent on the edge, which means that it can collect telemetry from the infrastructure or various services, things like databases, web servers, and any sort of system that you might want to monitor. But it can also run as a centralized gateway, which means that it can receive telemetry from other collectors or other OpenTelemetry components, centrally process them before sending them to an observability backend. So we'll mention some components that are really useful when it comes to Kubernetes observability specifically. We start with the first group, which is the cluster level monitoring receivers. And here we have the K8s cluster receiver, which is a component that can connect to the Kubernetes API. It receives cluster level metrics about the Kubernetes objects of that cluster, essentially reflecting their state over time. And this component should only run once per cluster, which is really important because otherwise you can have data duplication. So we call it singleton mode. So keep this in mind as well. And it can replace the need for the kube state metrics project, which is usually something that is a requirement for other observability agents out there. Here we have some sample metrics. We can see things like the pod phase, how many active jobs a cron job has, and things like that. Next, we have the Kubernetes events receiver, which again connects to the Kubernetes API, and it can collect Kubernetes events from the cluster, emitting them as OpenTelemetry logs. This can be useful because we see events about pod failures, restarts, scaling actions, or scheduling events that are taking place on the cluster. Again, this should only run once per cluster, singleton mode, and it also enriches the component, enriches the events with Kubernetes-specific metadata, which is really important because we can correlate these events with the actual Kubernetes workloads and the infrastructure of the cluster. In this example here, we have an event that indicates that a specific container image is being pulled into this specific Kubernetes node. Next, we have the Kubernetes object receiver. This component can run either on watch mode or pull mode. It can retrieve Kubernetes, raw Kubernetes objects from the API, and it can emit them as OpenTelemetry logs again, which is really useful because you can store the raw objects in a backend, in your observability backend, and then you can further analyze them later. You can investigate rollout failures maybe. You can even draw entity relationships if you want using this data. Next, another super useful one, the Prometheus receiver. So this component can scrape metrics from Prometheus endpoints. And this is super useful in Kubernetes specifically because it can be used to scrape metrics from the control plane of Kubernetes and any other services that already emit their metrics in Prometheus format. This is great because this component bridges the gap between the two ecosystems, Prometheus and OpenTelemetry. And in OpenTelemetry specifically, we have some extra features like distributed scraping, something that we will mention later. Then we move on to the next group, which is the node-level monitoring receivers. Here we have the kubelet stats one, and this component runs on the Kubernetes node, and it connects to the local kubelet of the node and retrieves metrics from the stat summary specific endpoint. Metrics there are about resource utilization of the node, the pods and the containers that run on this specific node, and as we can already imagine, this runs one for every single node of the cluster. So typically this is part of a daemon set collector. Again, as part of the daemon set collector, we will find the file log receiver usually, which scrapes the container logs from the files of the node, and it comes with built-in support for various container runtimes. It specifically implements the container parser, which can be used to parse container-specific formats, and yeah, known runtimes like Docker, Containerd, CRIO are already supported there. Next one is host metrics receiver, and again, this runs as part of the daemon set collector, and it can collect low-level system metrics from the underlying host, and yeah, from the underlying host, and this can be useful when you want to investigate issues, for example, and the Kubernetes APIs cannot provide this granular data for you, or the APIs are not responsive, for example. So next we have processors, and we have the, I think
too much here.
Yeah, this one is tricky.
Yeah, sorry. There you go.
Okay, processor. So the Kubernetes attributes processor, this component can be used in order to collect Kubernetes-specific metadata from the API, and this actually enriches the telemetry with Kubernetes-specific context. And this improves our telemetry a lot because we have Kubernetes-specific attributes on our telemetry, which can be used to filter out the telemetry or can be used to have signal correlation based on specific Kubernetes attributes, things like the deployment name or the daemon set name. Next, we have a really powerful component, the transform processor, which comes with support for OTel that you might know already, OpenTelemetry transformation language, which allows us to write declarative expressions so as to transform our telemetry. And this is super useful because it is declared within the configuration of the collector. So in order to transform our telemetry in custom ways, we don't need to write custom code. We can just use the configuration for this, which is super cool. And then we have a really extensive set of components that the collector supports. We're not going to mention all of them today. Here is a list that you can check out later if you want. And yeah, back to Jacob to talk to us about deployment strategies.
Thanks, Christos. So we're going to start with the most basic deployment strategy, which is sidecar. We're probably familiar with running sidecars in Kubernetes, something like Istio. Maybe you're running an Envoy sidecar, tons of sidecars out there. The collector is able to run it as a sidecar. This is really useful if you want like really granular telemetry collection, if you want to do really granular configuration rules, like per application. But obviously this does come with the trade-offs of running sidecars, mainly is that it's expensive. You're running, one agent per every pod. That is very expensive in my opinion. And yeah, it also is hard to manage updates. It's hard to actually push those out if you have that many different configurations. It's one of the problems we'll talk about a bit later. The next method is probably the most common, the most useful, is the daemon set. And daemon set collectors run once per node, as daemon sets are. It's very efficient. It's really useful to run it in daemon set mode because you can do all of those really helpful receivers that Chris just mentioned earlier. All of the power of a lot of the OTel Kubernetes ecosystem is most useful in daemon sets. It's really great for logs, really great for node metrics. But obviously the main problem here is you might have a node failure, and if you're forwarding all of your telemetry to node local, if that node does go down, if that collector goes down, you miss all of that node's data, which can be problematic. Next is the deployment. This is really useful if you're just forwarding telemetry along. You already have something else that's getting your logs, getting maybe some node level metrics. You really just want to forward traces and metrics. It's really helpful for doing central aggregation. It's very easy to manage and scale. You add on an HPA, and you're off to the races. This does have a few problems. Namely, it is a bottleneck, right? If you're not scaling it effectively, if you haven't configured that well, if you're not using the operator or the Helm chart, which does help you configure this can get tricky. It also is difficult to collect node-level telemetry. Not the best way to do that. Lastly is the gateway pattern. Gateway pattern is sort of a best of both worlds. You're doing local collection on a node and then forwarding that to a deployment as a gateway to do central processing. So the idea is that your node configuration is pretty much all receivers, and then your gateway is all processors. That way you separate each of those concerns. It's very scalable. It's really easy to repeat this across a bunch of clusters. Next, I'll talk about the OpenTelemetry operator and how it helps out. So the operator, or an operator, for those who aren't familiar, is a way to introduce custom resources in Kubernetes. It's a closed loop for consistent behavior and enables really powerful abstractions with really minimal configuration, as I'll show you in a minute. The OTel operator, I'm going to talk today about three main features. We have a CRD for OTel collector configuration. We have another CRD for auto instrumentation. And lastly, we have a CRD for distributed scraping and sharding for Prometheus with a component called the target allocator. So the collector CRD is very simple at its most basic way. It basically just embeds a collector configuration. It provides a bunch of sane defaults for those as well. It has support for all of the modes that we talked about just before. Also, you can configure pretty much any field that you need to within pods, replicas, deployments. It also automates a lot of the Kubernetes mechanisms for you, creating services, setting ports, doing RBAC if you configure it to do that. And it also gives you those default collector configs. Next is the instrumentation CR. This is probably the most powerful CR in the ecosystem. This allows you to auto-instrument your applications. It follows the OTel semantic conventions for best practices for resource attributes, and it also supports sampling configuration and various collector exporter destinations as well. There are a whole host of languages that we support. I think this is the exhaustive list. There might be one or two that I'm missing, but we add new support for these pretty regularly at this point. And I'd say Java and Python are the most used, and we see a ton of awesome usage from those. Lastly is the target allocator CRD. Target allocator is a component developed within the operator that enables distributed, sharded Prometheus scraping. It allows migration from the Prometheus operator for dynamic scrape configuration, meaning that we can actually support service monitors, pod monitors, scrape configs, probes. Basically anything that you're using in your current Prometheus setup, if you're using the Prometheus operator, you can migrate that directly to OTel with the target allocator. Now back to Christos to talk about the OTel Helm charts.
Sure. So probably in this room we are already familiar with Helm, which is another CNCF project. But in short, Helm is used as a package manager for Kubernetes specifically, which means that we can package our applications and distribute them as Helm charts using the repositories. And this means that we can have repeatable updates, instant rollbacks, and in general, more predictable installations. So for OpenTelemetry, we have 4 different Helm charts. We have a Helm chart for deploying the collector, another one for the operator. We also have a specific one about the OpenTelemetry demo, which is a standalone sample application that the project maintains. And we also have the OpenTelemetry KubeStack, which is an opinionated Helm chart, which we'll be talking about later. So as an example here, we can see how the collector can be installed using the Helm charts. So what we need to do in our environments is to include the OpenTelemetry Helm charts, add the repo, and then we can use the Helm install command to install the OpenTelemetry Collector using a specific values file so as to provide additional configuration if we need it. So in these values files, usually we can extend the default configuration that the Helm chart is coming with. We can also define the mode that the collector will be running on. This can be daemon set, deployment, or stateful set. And we also have support for presets. So with presets, we can have advanced concepts of the collector being configured automatically for us. For example, we have the logs collection preset, which automatically sets up the file log receiver for us and takes care of all the required volume mounts so as for the component to have access to the logs on the disk. And another example is the Kubernetes attributes preset, which automatically enables the Kubernetes attributes processor, automatically taking care of all the required permissions that this component needs so as to have access to the API, which makes the configuration really minimal and makes the whole onboarding for the users smoother, which is really great. And then we have the KubeStack. What about this?
Yeah, so the KubeStack is a new chart. It's, I'd say, alpha right now. We're hoping to get it to a beta soon. But what it does is a sane default configuration for monitoring Kubernetes. If you're familiar with the Prometheus stack chart, this is our version of that. We actually have a migration path from the Prometheus stack chart to an OTel collector approach as part of this offering. This installs an operator in the cluster. It can also optionally install auto instrumentation for you and hook that up into all of the collectors that you see on screen now. It's a really great chart for getting started in the OTel ecosystem. Now back to Christos on some advanced topics.
Cool. So first one is Kubernetes auto discovery. So with auto discovery, we can dynamically discover and monitor moving target workloads on environments that are really dynamic like Kubernetes, where applications come and go and we don't have to restart our agents. So this is quite important. So the collector comes with support for auto discovery, which means that it can watch the Kubernetes API, and when something interesting happens, like for example, a target application is deployed on a node, the collector will be notified about this, and if specific conditions apply, it can change the configuration automatically, and it will start collecting telemetry from this target application, for example, metrics and logs. This is something really useful because you can understand that we don't need to tune the configuration manually, especially when the applications come and go really fast, and the collector will handle everything during runtime. So this is great. And in order to achieve this, we can use the receiver creator component of the collector along with the K8s observer, and we can enable the discovery mode. And as people that we deploy on Kubernetes, then we just need to annotate our use specific annotations to annotate the workloads. And in this example, I have an Nginx deployment. So I annotate the workload indicating to the collector that it should be using the Nginx receiver to monitor this. And I also provide some specific configuration for the component. And that's it. Then next topic is about leader election. So the collector has support for, has an extension called leader elector extension, and we can attach to this extension receivers, and these receivers will start doing actual work only then when they will become the leaders of the cluster, the leader of the replica set of the collectors. So to illustrate this, we can have a daemon set, for example, of collectors, and all of these will start competing for acquiring a specific Kubernetes object from the Kubernetes API, Elise, that's the object, and only one will succeed. And once this collector becomes the leader, all the collectors that are attached to this extension will start doing work, actual work. So typically this work is cluster level monitoring things. So imagine K8s cluster receiver, for example. So you don't have data duplication with this pattern. Next topic is about log resilience. So usually logs can contain crucial information, so you need to ensure that they are always captured. And sending the logs directly from the OpenTelemetry SDKs over the wire can be error-prone because if the network goes down, you might lose these logs, and you don't want this. So another alternative approach is to have to configure the SDKs to write the logs down to the disk, and then you can have a collector to come asynchronously and collect the logs from the disk, which is a more resilient way. There is also a specific blog post about this. You can check it out if you're interested. And then last but not least, telemetry standardization or semantic conventions. So in OpenTelemetry, we have a working group within the semantic conventions project that specifically works on standardizing the telemetry for Kubernetes. So we have achieved already to have a really extensive set of metrics and attributes defined within semantic conventions. And right now, the group is working on standardizing this telemetry and releasing these semantic conventions as generally available, hopefully really soon. And yeah, next is about operational challenges.
Thanks. Yeah, so we're going to end with just talking about some of the considerations and challenges with everything that we talked about today. So I'd say the main thing when it comes to Kubernetes, as I think we all might know, is resourcing. It is really important to do some resource planning to consider the amount of volume that you're going to get and right size your collectors. Telemetry is important data, right? It's how we understand if things are going right or wrong, and so we need to be sure that those agents are successful. You should plan ahead based on some of the recommendations that we give online in our documentation to right-size your collectors. Next is configuration. I think another problem that is very ubiquitous in Kubernetes is configuration sprawl. This is no different with OpenTelemetry. I'd say that the operator and using the CRDs is one way to cut down on that configuration sprawl because all of it is going to be encompassed in a single CR. However, either way, you really do need to consider how you're going to layer various environments over a base configuration. It's my recommendation that you really try to only right size on resourcing and any environment variables like keys and secrets, anything like that. Lastly, back pressure. Christos mentioned this a little bit with log resilience, but there are a bunch of different ways to configure OpenTelemetry to handle back pressure. Mainly, we need to think about queuing. Are we going to just hold on to this while the downstream is unhealthy? Spooling, sending it to disk in order to retry it later, or actual back propagation, sending it all the way back to the SDK to have the SDK make a choice. Each one of these has tons of pros and cons that I can't get into today, but it's really valuable for you to spend some time with your team when you're planning an OpenTelemetry installation to be sure you know what's best for you. So today we've gone over OpenTelemetry, Kubernetes, Helm, operators, semantic convention, and we've talked all about why OTel and Kube is about love. Thank you very much for coming. You can find us in Slack over here. We have, I think, 3 or 4 minutes. If anyone has any questions, please come up to the mics. Really happy to take anything about OTel and Kube, anything you might have on your mind. Yes, please.
Hey, good morning. First of all, thanks for the session. Regarding the actual infrastructure for the metrics for the enterprise level, where it will get stored, or do you have any recommendation, especially on your diagram, OTel, actual backend?
Yeah, like where to store it?
Storing the metrics.
Yeah, I'd say it's really what works best for your environment. I really enjoy ClickHouse as a backend store. It's really flexible, very simple to integrate with OTel. There's an exporter that allows you to export directly to ClickHouse from a collector as well. Prometheus is another great option for metric stores. You also want to be sure that you're keeping in mind long-term storage. Prometheus is good for short-term, but you'll probably need something like Mimir, Thanos, or Cortex in the long term.
Thank you.
No problem. Thank you.
You mentioned the pattern of writing things to disk, and then so you don't lose logs over OTLP.
Yes.
Do you also recommend that for other telemetry formats as well, like metrics and traces, because those are also important?
Yeah, so I don't think that you can do that today with metrics and traces in terms of actually like replaying them, mostly because of some backends don't support out-of-order samples for metrics, and traces have, I think, a similar problem for some backends as well. Logs can come in; they don't depend on another resource, and so their timestamps can come in independently of one another. I think is the main reason why. It's also more common to see techniques like log rotation. You usually don't see that with metrics or traces. But you can, and I have written to disk with that spooling technique where you write it to a file, collector dies, and then when it spins up again, you read it from that volume and then send it off. I worked on a product where the backend did accept that, but I know that that's not a thing that everybody will accept.
Can you go back to the events processor slide? Or the events receiver?
And yeah, sure. Going as fast as I can. Yep. Yes, this one.
The orange slide, what do you mean by only run once in a cluster?
So you can have a deployment, for example, and with one replica, and in this you ensure that you only scrape once per cluster for the whole cluster. If you enable this as part of the daemon set, you have like 10 nodes, for example, you will have 10 collectors, so all the collectors will scrape the same. So you will store the same, you have no duplication, you have 10x the same data.
So only one instance, you mean?
One instance.
Okay,
Yeah.
You can have patterns like high availability if you want, some more advanced patterns, but the recommendation is to have a deployment and only once per cluster.
Okay, thank you.
You could also do, as Chris just mentioned, you could do a deployment with multiple replicas with that leader election extension, and then run it in a leader-follower pattern.
Got it.
If you want to do that in high availability mode.
Okay, cool. Thank you.
Yeah.
Hi, thanks so much for the talk. For the Helm charts, the options like enable log collection, those are super convenient. Like the high level, just turn it on once and you get all the config. Do you have recommendations for like observability backend providers who want to extend this and add more like easy option out of the box configs? Is this something the maintainers are thinking about?
Yeah, so I can speak to this from the operator perspective. The Helm charts, the presets that we have there, unless there's something that is like a very, I guess, default configuration that people want, it's really hard to get those in there. But the operator, we've been thinking a lot about distributed collector configuration to do these types of presets. We have some work down the line that some folks from Splunk are doing, where it's going to be a single CRD that gives you all of these presets by default, and you shouldn't even, like, all you basically will give it is just an endpoint to send the data to. Eventually, though, what we want to do is actually have a distributed CR for exactly what you're talking about for presets, and that will be later down the line. There's a lot of considerations there with just the OTel collector model and the Kubernetes model and how each of those things interact and don't interact well. But I'd love to talk about that more if you come to a SIG meeting. And we are talking actually, we're meeting tomorrow at the observatory. I don't know the time. So join Slack, go to the OTel operator channel, and we'll post it there.
Okay, which SIG?
Oh, the operator SIG.
Okay,
Yeah.
thank you.
Hi there. One thing I didn't catch up was in all of the YAML files where an endpoint is mentioned, where I am configuring credentials for the actual endpoint.
It's a great question. We don't have it in there because it's just extra. We're trying to make it like limit it, but under where it says endpoint right there, you can supply headers. There are also extensions that allow you to do OIDC, SAML, like various authentication methods. You just have to add in those extensions.
Okay.
But there is authentication.
Yeah. Okay.
Keep your endpoints authenticated.
And one other thing, when I have a global CRD configuration for all of my one type of use thing, and then I want to make an exception. For example, if I have a new version of my code and then I want to have something slightly different, is that possible to, I don't know, add another CRD which is then not, or which is overriding the global config?
Are you trying to do like a canary deploy?
No, for example, we have sometimes cases where we have to operate some customers a little bit differently, and then the schema changes or something else.
Yeah, so I think that goes back into the topic that I just mentioned, where it's distributed collector config, where you're going to want to be able to do these overlays for different tenants. The architecture of it, there's so many different ways to do it, and we haven't agreed on the right method for it because there's a lot of considerations and a lot of different use cases there. And we don't know. We haven't decided on what that looks like yet.
All right.
Yeah, but it is something we are thinking about, so it's a good question. Thank you.